Hello viewers, welcome to Young Maths Academy. Today we will be considering the theorem on the board. We want to give the proof to this theorem on the board today. The theorem states that the angle subtended by an arc at the center is double the angle subtended by it at any point on the remaining parts of the circumference. This is a very important theorem under circle geometry that we apply while solving questions. So let's take the proof to this theorem. I will have to rub off the board. So I say proof. Consider the circle. Consider the circle PAQ. Consider this circle PAQ with let's say with center O. With center O. Here the arc PQ. The arc PQ subtends the angle POQ, that is, can be written as the angle POQ at the center O, where P A and Q are points on the circumference. Okay. Also, extend a line. So it could be a dashed line, a line from point A to the center O. Also, connect. Let's use the word connect. Connect a line from point A to the center O and extend it to another point B. Extend it to a point B We have to prove that P angle PAQ is equal to twice of angle POQ. From here, I have been able to state some relevant points and angles for us to carry on with to prove this theorem. So the next thing I will do is to create a circle and solve ends from there. So from here, I will just say I will rub off the board. Sorry, because of space. Rub this off and draw out a circle circle this way. Let this be point P on the circumference and point Q on the circumference. This is A. I have this chord comes this way to point B. I have another chord comes this way. So this center O at these points. So I'll create kind of dashed line that joins this point O. Then I will extend this. I will extend this to a point B. Let this be a point B. Very good. Likewise, I'll create a diameter. Diameter PQ. PQ is a diameter. PQ is a diameter. Okay, from here we can carry on with our proof. This is center O. So I can this way. This center O that way. Okay. From here, consider the triangle APO. So if we consider this triangle APO, we can see that we have to read that this length is equal to this length, 2 radius from the center of the circle to the circumference. So we have 2 way that. So that is, I will say that is OA is equal to OP. OA is equal to AP or radii. From there, when you know that from the rule of triangles, when 2 sides are the same, their opposite interior angles will be the same thing. This is an isosceles triangle. Isosceles triangle states that when the 2 sides of the angles are the same, are equal, their opposite angles of the side lengths will be the same as well. So that implies that angle OPA is equal to angle OAP. So the angle here will be the same as the angle here. Okay. So another important theorem we will use, let this be equation 1. So using the property of exterior angles of a polygon, but in this case of a triangle, because we're dealing with a triangle. A triangle is a special type of a polygon with 3 sides. It's a trigon. So using the property of exterior angles, that is what it means is exterior angle is equal to the sum of the opposite interior angles, sum of the opposite interior angles. So exterior angle is equal to the sum of the opposite interior angles. What does that mean? This is our exterior angle. If you can see this very well, this is center O. POB is an exterior angle, and POB is an exterior angle here. So, and the opposite interior angles, the angle in A here and the angle here, P here. So, what that means is that implies that our angle POB is equal to angle OPA plus angle OAP. So from there, from one, we can see that from one, you can see that from one we know that angle OPA is equal to angle OAP. So in place of OPA, I can put OAP so that I have POB, and POB is equal to angle OAP plus angle OAP, and that's POB, and that means angle POB is equal to twice of angle OAP. Sorry, OAP. Let this be equation 2. Very good. We've been able to use this triangle to show that. Likewise, we'll also consider angle AQ, triangle AQ. Consider triangle AQO, or you say QAO, whichever way. So if we consider this triangle AQO, then we can also see, just following the same process, you can see that this length is same as this length. So two-way die as well. That is OQ. That is OQ is equal to OA. OQ is equal to OA. So that if OQ is equal to OA, the angle in opposites, the equal side lengths will be equal as well. So the angle here with the angle here has to be the same. So it implies that angle OAQ, that is, implies that angle OAQ will be equal to angle QAO. So angle QAO. So from there, that will make me rub off this, the diagram here. So I will just rub this diagram off to create space, so that from these points here, we can also say by property of exterior angles, just same property of exterior angles, that is exterior angle is equal to sum of opposite interior angles. So it implies that what? It implies that our angle BOQ at that stage now, that's going to be BOQ, or we say angle QOB, whichever way. So I can say angle QOB or BOQ, QOB must be equal to the sum of angle OAQ plus angle QAO. So that at this stage, we rub this off here. So implies that angle QOB, or you say BOQ, is equal to OAQ can be QAO, can be replaced as OAQ since they are equal. So in place of OAQ, I can put this or this in place. So I will just say OAQ should be angle QAO plus angle QAO. So I have angle QOB is equal to twice of this QAO. I can call this equation 3. Now, very good. So what I will do next is sum equation 2 and 3. Equation 2 and 3. Equation 2 plus 3 means that I will say POB plus QOB is equal to twice OAP plus twice QAO. You can see that, and then that is just saying that POB, yes. So POB plus QOB is the same thing as our PAQ. If you remember how the circle works, just like this, we have a diameter like this. We have a line drawn up to the point of B. The center O was here. This is A, P, and Q. So P O POB. So POB, QOB. So POB, QOB makes up our angle here in total. So makes up our POQ. So this plus this makes us POQ. So implies that this is the same thing as angle POQ, which is equal to twice of this means I have 2 into angle OAP plus angle QAO, and I will just have to rub this off. I think I will rub this off, so that from this part you can see that angle OAP plus angle QAO, angle OAP and angle QAO. So this is one full triangle, this is another full triangle. So the sum of this angle here, the sum of this triangle with the sum of this triangle make up this PAQ. So makes up this whole triangle here. So PAQ means this is PAQ. So that is angle POQ is equal to twice of angle PAQ. So, and that is our aim, to show that angle POQ, we want to prove that angle POQ is twice, angle POQ is twice of